Hi and welcome to the import and export lesson of the First Steps course. In this lesson you will learn how to import and export different geometry types and FEM models. We will start by importing a cantilever beam geometry from different data types, modifying it a bit and exporting it with the original data type. Also, we will import a topology optimization result. When you start working on your own projects in ELISE, you will regularly need to import and export data. Learning it on this very simple example will give you a head start and help you transfer that knowledge to your own projects. We start here with the inputs, and these are three different file endings or data types, so you can select whether you want to import the step file, the STL file, or the XT file. And to do so, you connect it with this file ending basic container, pick whichever you like and connect it here. And if you open the material folder for this lesson, you see that here we have three different cantilever beam geometries stored of different data types, and by selecting one of these file endings you select which one you would like to import. And also what you can see here is that the name of all of these three geometries is exactly the same, so it's always cantilever beam. So here we have selected the file ending, and now we would like to actually import the part. And to do that, we will first merge the name cantilever beam with the file ending .stl. Use the component merge text to merge these two together. And if you now connect the output to this prepared panel, you can read cantilever beam.stl. And now we would like to import the cantilever beam.stl, and we have to give a file path for that. And because this ELISE file is stored in the same folder as the STL, we can use the relative file path, and then we get the file path to where this ELISE file is stored. And now we would like to import the geometry. And here you can also enter a tolerance. If you don't do so, the default tolerance of the file is used. Okay, so now we have our geometry imported. You can see it already in the viewer. We connect this here to here, and as you can see, we imported the STL, so it's a mesh. And if we change this now, for example, use .step instead, we will get the solid body, or if we use XT, we will get also a solid body. Okay, so now we would like to modify it a bit, just so we can differentiate between the imported and the exported part. So let's just move the cantilever beam a bit so we can later see the difference between the two of them. So here I will use the move component and then use these number sliders to construct a vector. If you connect them, you will get a vector that you can use for the translation. And you can play around here, change this up however you'd like. Okay, I'm gonna make this original part invisible. So now we only have the moved one connected into your output, and then we can go on to the next step. So next we want to export the moved part. So of course we could use the original file name, but then we would overwrite the original file, and I want to write into a different file. So we will use merge text again and just put moved in front of the original file name so that we know that, this is the modified version of the cantilever beam. Use merge text again, merge these two together. You can check this out here. So this is now the name for the new file that we will export. Okay, and then we will use that again together with the relator file path component. So here we get our file path and we will write into the same folder as where this ELISE file is stored with this file name. And now we're ready to export our moved geometry, connect the moved part, and here we can read that our export was successful. And if I now open my folder again, you can see that this was newly created. I now have the moved cantilever beam here. You can go back to the beginning now and exchange the data type again, or the file ending. And here also this will change. And if you open your folder again now, we have two different moved cantilever beams, one for each file ending that we connected. Okay, so this was about importing and exporting geometry. We will now talk about how to import a FEM model on the example of a topology optimization result. And we won't talk about exporting because if you run a topology optimization, or the same goes for a FEM analysis, then the program will write the files automatically that you can later import. So it's exported automatically when the simulation or the optimization is running in ELISE. So here we have the files that we need to import the results, and those were written in the optimization automatically. So these are the files or the file endings that are interesting if you want to import FEM models. And the name of your FEM model will be in front of the file ending, and the .dens file contains your density results, the .disp file contains your displacement results, then you have your stresses in the STRS file ending, then you get also your shell thickness optimization results with the FS thick file ending, and cross-section optimization results in the .prop file endings. Okay, so if you want to import the topology optimization result, you need to select the .fem file, and then in front is the name of your FEM model that was optimized. Again, we will set the related file path, as those are all stored in the same folder, like this. Another thing you could do is get the related file path component on the canvas, double click on it, and then select your .fem file directly like this, and then you will see these three lines, which means that what is stored in the panel here is internalized in this container directly. So both ways work equally. So now we would like to import the FEM model like this, and we can read here the information, and here we have our model output. We connect it to our output here, and we can continue to the next step, which is displaying the imported model. For that we need the result isomesh component, and if you would like to learn more about it, go to the topology optimization session of the First Steps course. Okay. And as you can see, we get an error, which is that the component is unable to find the density results. And the reason for that is that we have not selected that we want to import our results. So right now we are only importing this .fem file, but not the results. If I select that I want to import the results, this component is independently searching for the result files, for example, .dense in this case. Let's plan it out. And then we get our isomesh and can display it. In this lesson, you learned how to import and export different geometry types and FEM models.